All right, so let's get going on today's class. All right, so today we're going to start our look at memory. We've left perception, we've left visual imagery, and now we're going to turn to a new topic, which is memory, a very important topic, and one of the first to be tackled in cognitive psychology. So to that we now turn. So what we're going to do today is we'll just very quickly recap a couple of those examples of extreme memory, and then we'll take a look at an overview of the modal model of memory, which is the idea that there are different components to memory, different structures to memory, basically different modules of memory. And we'll take a look at the ones that have been identified: short-term memory, working memory, and long-term memory. And then, as has been a theme so far in this course, especially in the perception section, we're going to take a look at some of the problems with certain of these definitions, just to make you aware of some of the issues with memory research. And then we'll take a look at some evidence for memory structures, actual evidence that backs up the idea that we have these three different types. And we'll take a look at some of the CogLab. So we'll begin with the suffix effect. And then we'll take a look at different types of long-term memory. Probably not all of this today, but we'll see what we can get through without rushing. We'll take a look at explicit versus implicit memory. And then we'll take a look at the implicit learning, CogLab number 6. And then finally, we'll go back to some evidence for these actual different memory structures. And in our look at memory, we're going to take a look at a very interesting case, the case of Clive Waring, where this individual, because of a virus that he contracted, literally cannot remember anything that happened before he had his virus, and he cannot form any new explicit memories, new conscious memories after that. So he literally has no memory of the past, and he cannot form any memories of what is occurring. So he lives in a 20-second time window, and we're going to see just what that means for how our memory operates and how important memory is to basically what makes us human. All right, so just to kind of recap, we have seen the good and the bad in terms of memory so far. So one place that we saw the bad was change blindness. So change blindness relied on memory. You needed to recall what a person looked like, what a scene looked like, in order to detect a change. And we found that we were very bad. Humans are very bad at detecting certain changes, indicating that your memory for that scene is actually very poor. It's very vague. It's not detailed. You can contrast that with the extremely good examples of memory. And we saw Stephen Wiltshire, who basically has photographic memory for scenes. And we saw how he, after one helicopter ride, was able to very accurately draw the New York skyline. And he's done this for New York. He's also done it for Rome. And when you compare what's actually there on the skyline to his picture, it's almost as if he was tracing a photograph. So we've seen the highs and the lows. So now let's take a look at what memory actually is. So the definition of memory, the broad definition of memory, is that it is simply the process that is involved when you use information, when you process information, after that information is no longer present. So it's, and that kind of covers the idea of memory. It's when you have to bring about or recall information that you have previously seen in order to process that information. So it's not perception where you're processing information that is present, right? You're looking at it as seen and you're processing that information. It's different. It's where you process information that is no longer present. That all falls under the umbrella of memory. All right, and one of the biggest kind of concepts, paradigms underlying the study of memory is the idea of the modal model of memory. This idea that we have different types or different mechanisms with which we remember information that is no longer present. So the modal model of memory proposes three different types or three different modes of memory. We got short-term memory, and this is the system that is involved in storing small amounts of information for a brief period of time. So short-term memory is the memory where if somebody tells you the directions, to a particular area on campus, if if you're looking for north side and you're like, I don't know how to get to north side, and they say, all right, what you want to do is you want to go out these doors, you turn right, it's going to be the big building on your left. You have to remember that that is a small amount of information and it gets only stored for a brief period of time. So that would be subsumed under your short-term memory. Other memory proposed by the modal memory model is working memory. And this is a very, once again, limited capacity system. And this is for the temporary storage and manipulation of information for certain tasks. So working memory is involved. If you've ever tried to do a math problem in your head, that is where working memory gets involved. So if somebody says, can you multiply 12 times 14? And you're in your mind going, all right, 12 times 14, let's start with the 2's. 2 times 14 is 28. And then we do the 10's. 10 times 14 is 140, so it's 168. That process is involved in working memory, where you're actually manipulating that information. And one of the first massive papers that was published in cognitive psychology was about working memory, and it was on the magic number for working memory, which is 7 plus or minus 2. And 7 plus or minus 2 refers to the fact that we really only have the ability to hold 7 different pieces of information in our minds at a single time. And that, I think, is one of the main reasons why phone numbers, as they evolved, stayed within 7 digits, right? It was always the area and then that 4 digit afterwards. And that's because previously, when you actually had to remember phone numbers, that was the limit of your memory ability. So that's working memory, where you actually manipulate the information, not just remember it, but manipulate it. How much capacity do you have for that? And then finally, we got long-term memory. And long-term memory is, once again, a separate system, a separate proposed system that is responsible for storing information for long periods of time. So if somebody asks you about your favorite Christmas memory from childhood, that is going to be stored in your long-term memory. So if you can access it, you can remember that wonderful Christmas you had when, you got, that play set that you were really, really hoping for. Long-term memory, anything that, again, you've learned usually gets hopefully stored in long-term memory. And long-term memory, unlike these other two modal processes here, long-term memory seems to have almost an unlimited capacity. We have not yet discovered a person who has a normal functioning memory who has ever said, you know what, I can't remember anything else anymore. My long-term memory is filled, right? We kind of have that. Some people think that, well, the only way I'm going to remember anything new is if I forget something. But that doesn't seem to be the case. Long-term memory basically almost seems to be unlimited in its storage capacity. All right, so those are the definitions. There actually is evidence for these, but one of the criticisms of this model of memory has to do with these definitions, and it has to do, once again, with the problem of definition. And in these definitions here, even though they sound very reasonable, even though they seem to say a lot about short-term memory, working memory, and long-term memory, we're going to see that they don't quite hit the mark. And while they might be useful to guide research, we also have to be wary of thinking that we understand things or that they're true just because they have either reasonable sounding definitions or just because they have researchers after them that have published on this work. So what's some of the problems with these definitions? Well, let's illustrate it with some other definitions where the problems will be obvious. So let's say that I decided to enter the memory field, memory research, and I said, all right, you have your 3 processes of memory. You got short-term memory, working memory, long-term memory. I have actually identified another mode of memory. I have identified what I like to call blue memory. And what blue memory is the system involved in storing information regarding things that are blue. So we definitely have blue memory. So if you can remember what a blue whale is, you have blue memory. If you can remember what a blue rose is, and know that these do not occur naturally, you have stored that information somewhere in your blue memory. If you know the name of these creatures, you have stored Smurfs in your blue memory. And yet, something seems a little off about blue memory. It seems weird to say that just because we can remember these things, we have to have a separate process for remembering them. Let's take it a step further and say that I also propose the system of Spider-Man memory. Spider-Man memory is the system that's involved in storing anything, information related to Spider-Man. So the fact that he has a red and blue outfit and that he's part of Marvel Comics, the fact that Tobey Maguire played him in the original series, got replaced by Andrew Garfield, the fact that Spider-Woman exists, and she was created in the early 80s to protect Spider-Man's copyright because a rival company was going to bank on Spider-Man's popularity by coming out with a Spider-Woman cartoon. So Marvel put out a Spider-Woman comic book so they could secure the copyright. All of that is stored in my Spider-Man memory, right, where I store all my information specifically that has to do with Spider-Man. So these 2 examples here, Spider-Man memory, blue memory, they seem ridiculous, right? And I wouldn't propose this seriously as different processes in memory. But notice that basically I've taken a process and defined it in terms of that's what it stores, right? So I've said, all right, there's Spider-Man memory because we remember things regarding Spider-Man. So I'm going to say that this is a system involved in storing information that is related to Spider-Man. And yet this is somehow unsatisfying. And you'll notice, if you take a closer look at these definitions, that they basically do exactly the same thing. So if we take a look at short-term memory, short-term memory here literally says there's a memory process, not for Spider-Man, not for blue things, but for short-term memory. And it's defined as short-term memory. And what does it do? Well, it's a system that stores things for a short term, right? It's a short-term memory system. Why do we know it exists? Because we store things for a short term. This is just as unsatisfying as saying there's Spider-Man memory because we remember Spider-Man things. Take a look at working memory down here. Working memory is a limited capacity system for temporary storage and manipulation of information. So working memory is the system that we use to work with memory, right? Once again, it's this kind of circular definition. It's this sort of thing where it's not necessarily true just because the definition sounds convincing. And then finally, we got long-term memory down here. And long-term memory, you can kind of see the pattern here. Long-term memory is a process that stores information for the long term, right? So once again, it's almost like an empty definition where in order for this to actually be convincing, and just for foreshadowing, it is convincing, but in order for this to actually be convincing, we need some sort of evidence that these processes actually exist. And the evidence that we remember things for a brief period of time, the evidence that we work with information, and the evidence that we remember things for a long period of time is not enough to say that we actually have these different systems in our mind. So always bear that in mind. Always take a look at the definitions that you're working with and ask yourself, are they circular? Do they actually provide information? And most importantly, with memory, is there evidence for these different systems? As we're going to see, there actually is evidence for these systems. Well, let's turn to some of the different models of memory that incorporated the idea that we have these three different systems, that we have short-term memory, working memory, and long-term memory. So the first model we're going to look at is from Baddeley et al. 2009. And he proposed a theory of working memory where he went beyond the idea that working memory is just for working with memory and actually kind of started to make predictions and illustrate processes about how this memory would actually work. So in Baddeley's working memory model, we have what he liked to call a central executive system. This is what decides what it is that you're going to try to remember. And then there is a visual spatial sketch pad. This is, and you can see these little refresh loops here. This is where you store any visual information. So this is where you would store in working memory if somebody showed you a picture of somebody and said, try to find this face in a crowd, and then took the picture away. This is where you would try to keep that face intact. This phonological store, once again with this little refresh loop here, this is where you store auditory information. So this is where if somebody told you a phone number and they said, you know, they're like 555-4932, this is where in your mind you would sit there and think to yourself, 555-4932, 555-4932, 555-4932, until somebody interrupts you, breaks that loop, and then your phonological store goes away. So this is the idea of the central, Baddeley's working memory, and this interacts with visual semantics, basically your knowledge of visual language. Episodic long-term memory, also your interaction with the language that you've learned, which is part of your long-term memory. But this was taking that idea of working memory further and actually giving you these testable sort of testable models here that gives you details about how this working memory is actually working. All right, so that was Baddeley's working memory. We'll just take an overview of these theories just so that you're aware of them. Next one we're going to take a look at is Cohen, which is the fanciest researcher I've ever seen. But Cohen came up with this idea of an embedded processes model. And in the embedded processes model, you have stimuli over here that are coming in from the outside world. They get placed into a sensory store. This is kind of like a temporary place where you're processing the stimuli that are coming in. And then they get sent to this entire area of long-term memory. So you'll notice in this embedded processes model, let me zoom in on that a little bit. In this embedded processes model, long-term memory is basically the memory that you have. So that is your memory store. What happens is when you start thinking about somebody, you then activate a certain area of your long-term memory. So when you're thinking about what do I need to pick up at the store, you start activating things having to deal with what you remember to be in your house, what you ran out of, what a store is. You start activating these things, forgetting about everything else, forgetting about how cars work, forgetting about what's in your Netflix queue, all that kind of stuff. You activate a certain portion, and then this focus of attention is basically your working memory. This is what you're actually bringing out of your long-term memory to work with. This is what you're manipulating. And again, we have this idea of a central executive that controls the functioning of this embedded processes model. So you'll notice that in this case, short-term memory is not separate from long-term memory. It's not a different section of memory. It's just that it's your focus of attention that determines what's there for the short term versus what's there in long-term memory. All right, and one more. We got Broadbent, getting more relaxed now. And Broadbent's theory, his Broadbent's model of memory where this is one of the ones that became the most influential. This is one of the ones that we sort of come across most often in like introductory psychology courses. And this is the idea that we have information coming in that gets picked up by the senses. And then the senses have their own memory. This is called the S system of memory. And this memory is most easily experienced when somebody takes a flash picture of you and you close your eyes and you see the flash, the imprint of the flash when you're looking around. That imprint is this S system of memory. So it's kind of like the echo in your ears or the residual flash on your eyes that you have when your senses experience something. So it goes through this almost sensory memory here into primary memory. This is your short-term working memory. And that gets sent into this P system, which is your primary memory, which is kind of like an amalgamation of short-term and working memory. And then if you manipulate things enough or in the right way in your P system, then that information eventually gets into your secondary memory, which is your long-term store. So this is kind of the idea that if you study something enough, you work with it enough in your short-term memory, it will get transferred into your long-term memory, and you'll be able to recall it at a much later date. All right, so that was a very brief overview of the modal models of memory. So different ways to combine working memory, short-term and long-term memory. So now let's take a look at how some of this memory might actually operate. And one of the studies that kind of shone a light on some of the processes that underlie these memories was the one on the suffix effect. So here we go. So on the suffix effect, in each trial, you heard the digits 1 through 9 presented in a random order. I kind of laughed because the first time I tried this, I forgot to turn the volume on my computer. And I was just sitting there for a while going, I don't understand what's happening. So in each trial, you heard the digits 1 through 9 presented in random order. And your task was just to recall the numbers in the same order that they were presented in. So whatever strategy you wanted to use, you had to recall them in exactly the same order, kind of like a 9-digit phone number. So the independent variables, there was a couple of independent variables. Number one was the type of suffix. So the suffix is the signal that you received that indicated that your 9-number sequence was finished. So there was a signal that you received that indicated you heard all 9 numbers, it's time for recall. And the type of suffix could either be a speech or a non-speech. So it was either something that made sense, some word, or it was non-speech, which was a tone. And then the other independent variable was the serial position. What number, what position were you trying to recall? So the position of each digit in the list, was it the first digit? Was it the second digit? Was it the 7th one out of 9? That's the other factor here in determining your memory. So importantly, for the type of suffix, for the non-speech condition, it was just a tone. It was just a beep, or whatever it might have been, this version of CogLab. So, but importantly, it wasn't a word. It wasn't speech. In the speech condition, your suffix, your signal, was the number 0. And it's important to realize that as a signal, both of these effectively identified the end of your trial. So the tone effectively identified the end of your trial because you heard the tone. You're like, that's not a number. I can start my recall. The speech, on the other hand, also successfully identified the end of the trial because it was the number 0, and you were specifically told you were going to be presented with numbers 1 through 9. So your understanding of numbers indicated that the number 0 could completely be ignored. It's just a signal. You don't have to try to remember it at all. Your mind could completely ignore this speech. You could identify it as soon as you heard 0. You're like, oh, I guess I'm done. but you didn't have to try to remember 0. So once again, you would hear the 9 digits in a row, and then once you heard either the beep for the non-speech trials or 0 for the speech trial, you would enter in your numbers in order, and you would start your next trial. All right, so let's take a look at what happened. We're going to start with the results for the non-speech condition. And this, again, was where the signal to recall your 9 numbers, the signal to begin, was simply a tone. And let's take a look at how everybody did in that condition. So what we got here is we got the proportion correct. So this is the proportion of numbers that you got correct for each serial position. So if you were correct for that first number that you listened to, if it was a 6 and you pressed a 6, then you would be higher here on the proportion correct. So higher on proportion correct indicates more correct memories for that digit in the serial span. The lower it goes, the less correct you were, basically indicating that you did not have memory for that event. All right, so we got proportion correct, we got serial position. What did we do when the signal was a tone? Well, that is the pattern of data right there. So this is known as the serial position curve, and this is what typically happens whenever people try to recall information that is given in order and has to be done in a specific order. So what people would find is that in this serial position curve, this U-shaped curve, you tend to be very, very good at remembering the first things that you've heard. And this is known as the primacy effect. So most people in this study were really good at those first 3 numbers. So basically when that sequence ended, in most cases you would be like, all right, here we go. 7, 3, 2, no problem. But then once you get to that 4th number, you're kind of sitting there going, oh no, 8, maybe 6, I can't really remember. You start guessing around here. But then what happens is that as you get close to the end, all of a sudden your memory picks up again, and that's known as the recency effect. So we have 2 different effects here. We got the primacy effect, that first effect where we're better at remembering the initial numbers that we were presented with. And then we got the recency effect where we're better at remembering the final numbers that we were presented with, basically leaving those middle numbers not remembered, that information being lost. All right, any questions so far? So far, so good? All right. So the results for the speech condition, when the signal to recall was a useless 0. So once again, very important to remember, you only have to remember numbers 1 through 9. And this was in the instructions. So you knew that that 0 could be completely ignored. It was useless to try to remember the 0, but it was presented as that signal towards the end. All right, so there is the serial position curve for when the tone was the signal. Any guesses? For those of you not looking at the slides, it's going to happen with the serial position curve when it's that speech that is the signal. When it's the number 0 that's a signal. Do you think it will look the same, or do you think it will look different? Mm-hmm. Yep. No.
I think that maybe the ones at the end of the list will be less accurate because now you associate 0 with being the end of the list.
So that's one prediction, that the end of the list will be less accurate. Another possibility, so we got, yep.
I was just going to say that maybe like we wouldn't have that the recency effect as much because the 0 might blend in with the other numbers.
Mm-hmm.
So we wouldn't maybe realize that we were coming to the end of the list, like the tone.
Yeah, so same kind of an idea, that the 0 is going to somehow interrupt our memory system, somehow interfere with that. Mm-hmm.
I had this one, and once I got to the end, I couldn't remember the first freaking numbers because I was so concentrated on it. There was 10 numbers to me with the 0, and so like once I got to like the 6th one, I'm like, okay, I would say the first really quick, and then I would start focusing on the second half, and then when I was done with the second half, I'd forget all the first ones.
Mm-hmm. So maybe we'll get the recency effect to go down. a little bit more. That's also a possibility. But it's interesting that you mentioned that you felt like you had 10 numbers to remember, and you only had 9, and consciously you only have 9. And everybody here who was in that speech condition would be able to tell me 0 is not part of 1 through 9. So I am going to, if I got a strategy going in, whatever my strategy is to try to remember these numbers, and whatever my strategy is to try to remember these numbers, I'm not going to include 0 in that strategy. I'm going to ignore 0 because 0 is a signal, right? So just the same way that individuals in the tone condition wouldn't be sitting there in their mind going 5, 8, 7, 2, 3, 7, 4, 9 beep. 5, 8, 7, 2, 3, 7, 4, 9 beep. I got 2 7s in there, but anyways, they wouldn't be doing that. Same for you. Consciously, you would think your strategy, your mind would say to itself, 0 is not one of the things I got to remember. Forget about 0. You don't forget about 0. So when you do your suffix, in the suffix condition, when there's a tone, we actually do get that recency effect still occurring. So these are the 2 serial position curves. And you can see that the recency effect is still occurring for both of these. So we do have better recall for those first few numbers. It does start to get a little bit worse for the ones that had the suffix, the ones that had the 0 as a signal. But the biggest part of this comes into effect in the recency. And in the recency effect, you'll notice that there is a big gap between people who heard the tone and people who heard the number 0. And that big gap is weird because, once again, you shouldn't have even tried to remember the 0. So the fact that it decreased this ability to remember that last number indicates that you were in fact remembering that 0. You were in fact putting that into your memory system. All right, so that difference there, that is known as the suffix effect, and it's that drop in your ability to remember a sequence of items when the signal to remember the items is the same as the previous items. So in this case, you were trying to remember numbers, and when the signal is a number, you drop in your ability to remember those, and that is the suffix effect. All right, any questions about that? Make sense? All righty, so I got some questions. Okay, so we just saw the primacy effect and the recency effect. We talked about the modal memories, short-term memory, working memory, long-term memory. So what do we think? What modal memory system causes that primacy effect? What modal memory system is probably at work here to help you to remember those first 3 numbers better than basically any of the other numbers?
Working? Is it working memory? Because you're repeating it?
Part of it would be working memory. So part of it, there's actually a couple of possibilities. One of them is working memory. So one of the ideas is that these first 3 numbers can get into your working memory. And more importantly than just getting into your working memory, you get to rehearse them. You get to do them over and over and over again. So did most people find that that's what they tried to do when they heard the first numbers? They would just start repeating it to themselves and then just keep trying to repeat it as the numbers got added together? I'm going to take your silence as a sign. All right, so yeah, and that's what happens. So it could be working memory in this case, so that you rehearse these enough. Baddeley would say that you put these into your phonological loop and were able to rehearse them. So 3, 4, 8, 3, 4, 8, 3, 4, 8, and you were able to hold on to those. Or it's quite possible that these might have gone into some sort of maybe weak form of long-term memory, where it's not that you can recall them now. I think this was like about a week ago that you completed this. So it's not that you could recall it now if I asked you, well, what was the first 3 numbers on your last trial? You know, you probably don't remember. But for the time being, you got to push your memory a little bit longer, right? You got to hold on to this for 30 seconds instead of, you know, only 5 or 10. So it's quite possible that the modal memory system causing the primary primacy effect might have been working memory, could have been some form of weak long-term memory, but definitely something was going on where you were being able to maintain those first three numbers. What about the modal memory system that causes the recency effect? What might be the reason why you're able to recall those final two, or at the very least that final single number?
Short-term memory?
That is probably more to do with short-term memory. And it's more clearly to do with short-term memory, because by the time you get to this position here, you're not going to be able to rehearse this one very much. You're not going to be able to repeat this to yourself over and over again. So it's not like you're working with it or processing it in working memory to keep it alive. This one here is most likely due to some form of short-term memory. This one here is probably due to the fact that you just heard it, and before its memory can decay and you lose that information, you're able to punch in your digits and you get to that last number.
That be applied like when you're taking a test, the questions that are about like what we learned last are the easiest, especially for me. Like if there's like a bunch of questions about what we just covered, like the class before, those are like super easy. I'm just like, oh, that. But where if I have to like go back to like the first thing we covered, I really have to like work to like pull it out.
It's related to that. So that would go a little bit beyond what people typically think of as short-term memory. So short-term memory, there's different, people disagree on exactly how long a short-term memory lasts, but it's definitely not days. So the fact that, if we learn something on the Tuesday and you have your exam on the Thursday, whatever you're recalling isn't from short-term memory. I did have a strategy when I was taking exams that anything that I was kind of struggling with, I would try to put it in my short-term memory. So I would literally be reading my book, 5 minutes before the exam. And then when the professor was like, okay, book's away, here's your exam, you can begin. As soon as I got it, I didn't do the first question. I just wrote down everything that I was trying to remember, trying to get it out of my short-term memory into a place where I could store it. Now that I only had to remember for maybe 5-10 minutes. That's more in the window of short-term memory. But you bring up a good point. There is so many kind of like little intricate effects in terms of what can be remembered. We're going to see in a future lecture that your memory for events throughout your lifespan changes drastically. So you can remember more. There's kind of bumps in your memory. So you can remember a lot about what happened to you in the last month, but you can't really remember much about what happened to you maybe in the last 2 years. But you can definitely remember things from your childhood. Like you can remember a lot of stuff from your childhood. So throughout your lifespan, you kind of go up and down in terms of the memories that you remember. If you just ask a person, write down everything you remember from your life, write your autobiography, we'll see they remember things in kind of humps and valleys in terms of how much they remember. And it's very intricate how memory works. One last thing that I'll mention that is one of the ways that I design my test. If you test people in the order that they learned it, they are much better, about 10% better than if you test them in a random order. So that's actually been measured, where if your exam is the order that you learn things in, you will score 10% better than if the exam is just jumbled up and random. So, it's all these little things. And one last thing just to kind of mention, we're also going to see that as a foreshadowing, when you remember something, you also remember the context that you've learned it in. So this is one of the reasons why you might not remember memories of your childhood. But as soon as you go back to your childhood home, it just all starts flooding back. Is because in addition to remembering the event, you also remember the characteristics of where it took place. And this is one of the reasons why I pop a clock up here.
I always look at that thing when I'm trying to remember something.
Yeah.
I'm like, where was that on that PowerPoint?
Exactly, and that's why I pop a clock up here, because when you're learning in this class, 99% of the time, we got a nice bright screen here. So your mind has actually coded in your information with nice bright screen. There's a clock right behind you. Anybody could just be like, how much time is left in the exam? But help you guys along, pop it up here. It kind of helps you grasp, those memories. So memory there's a lot of things that affect memory. And, we're going to take a look at a few of those to kind of just scratch the surface. And it is one of those areas of psychology research where if you read a paper from a memory researcher, there tends to be like 5, 6 independent variables. And it's because so many things factor in to make these kind of differences. And it's very difficult to understand unless you're a little bit of a expert, and knowledgeable in that particular area. All right, so recency effect, probably short-term memory because you got to recall it almost immediately before it decayed, before it went away. All right, modal memory system caused a recency effect. What memory phenomenon was reduced by the suffix effect? Was it the primacy or the recency effect? So what was decreased the most by the suffix effect? It was the recency effect. And that recency effect was the one that it does affect things pretty much across the board, but definitely the biggest hit occurs for that final number, that final thing you were trying to remember. All right, and what modal memory system was affected by the suffix effect? What do we think? Why do we think the presentation of a 0 caused a suffix effect, but a beep did not? What does this indicate about what is happening in your short-term memory or your working memory? So let's take a look at, I thought I had the graph coming up, but we got it right there. So what does this drop here indicate is going on? Mm-hmm.
And maybe that like another number was added, so something got bumped out.
Something got
so,
bumped out.
Remember, like the phone number theory, where it's like seven digits in the short term.
Mm-hmm.
So that's just what I was thinking, because then the middle numbers got kind of bumped out too, because I remembered the first one's better, and so yeah.
So what's some of the? So I agree with that. I think that's exactly what's happening. What's some of the best evidence that one number got bumped out? Looking at this graph here, what's the best evidence that you're remembering that 0? So that if we asked you what was the signal, everybody would be able to say, oh yeah, 0 at a very high rate. But what's some really good evidence here at the end of the graph that indicates that it actually was the 0 bumping out that number? Not the first number, it's on the end of the graph.
The last number?
The last number compared to?
It's almost at the second.
The second last number. Yeah. Yes. So take a look at the ability of the individuals who are remembering with a tone signal. Take a look at their second last number and how well they did. Because this number basically bumped out their second last number. This number used to be in the last position. But when this final number that they needed to remember came in, it bumped it down to this position. Take a look at where the last number for people with a 0 signal is. It's almost literally at exactly the same level. And this is very strong evidence that regardless of your conscious efforts to keep that out of your memory, as soon as your mind heard 0, it said, oh, okay, I'm going to put that into your working memory. And now 0, if you needed to remember, it would be up here, but it bumps down your technically last number right at the level of the second last number of the people with the beep. So this is actually super interesting because it indicates that you don't have the ability to necessarily filter things out of your short-term or your working memory. And as much as you kind of say, I don't want to remember that, or I'm not going to pay attention to that, it works its way in there. It gets in there whether you want it to or not. So that 0 made its way into your memory. And you could tell yourself a million times, I don't need to remember the 0. I'm not going to remember the 0. And yet it was still in your working memory, in your short-term memory. Mm-hmm.
I was just going to ask, is is that also the conscious effort to not remember the 0? Would that also explain why the trial with the 0 is even just that little bit lower for the whole time? Looks like even from the third number, it's, it gets more, lower and lower.
Yeah, it's quite possible. It's quite possible that
some of that memory to try to avoid something.
So it's quite possible that you're using part of your memory capacity to try to avoid things. They found there's a lot of research that trying not to think of something takes effort.
Yeah, I think about it.
So the classic example is don't think of pink elephants.
Mm-hmm.
Everybody now is thinking of pink elephants, right? And it takes effort to suppress that. And that's absolutely one possibility, that your actual effort to suppress it used up part of your working memory, and that's why in general it seems to be detrimental to the entire memory system. There's another hand up. Oh wait, sorry.
I was going to say something similar, because when you showed the little model before about how you have like one like focus of attention.
Yep.
Something you can only focus on one thing at a time then. And so you're either, I think you spend half, like I was spending half the time 4, not 0, 5, not, so you spend like half the time through the whole thing, paying attention to 0.
Mm-hmm.
And only half the time paying attention to like what you're actually supposed to be paying attention to.
Yeah, and that's another possibility that's completely in line with this dropping here. But again, not that much of a drop back here, because nobody was paying attention to 0 over here, which is why probably this part of it is preserved.
The 0 was always in the same spot too. I mean, like it was the tone of the 0. So
Yeah.
I think that it just like I heard 0 like 50% of the time in the same spot.
Mm-hmm.
So I think that it was just like it becomes a pattern that I know it, but I can't discard it because it's a number still.
Yeah.
And how I remember it.
Yeah, and that's the key here. You cannot discard it. So that was a very interesting finding that came out of this suffix effect, because what it does is it indicates that in our working memory, we cannot filter out information. We can filter out, it seems to be we are able to filter out categories of information. We can say, I'm going to pay attention to numbers, but I'm not going to pay attention to beeps. We can kind of keep the beep from coming into our long-term memory, but we are unable to say, I'm going to, within a category, I'm going to remember 1 through 9, but I'm going to ignore 0. This is one of those instances where consciously that might be what you want to do, but you have no ability whatsoever, to do that. And this is just a kind of, we'll talk about this more, but this is one of the big reasons why controlling or somehow, well, maybe not controlling, that's the wrong word. This is one of the reasons why media is so incredibly important. And it's because you are being presented with information. And as much as you would like to say, I'm going to ignore that, or that's not going to have an effect on me, or I know that's not true, right? It's almost analogous to you saying, I know I don't have to listen to 0. I know that's not something I need to remember, but it's still working in your mind. And just like in the recency effect, where you practice something over and over and over again, and that's stuck in your mind more, and that's a lot of the times how people get things into their working memory. Think about the impact of hearing the same thing in media over and over and over again. Even if you say to yourself, not going to pay attention, or don't need to remember that, it gets in. You're unable to filter it out sometimes, like this suffix effect showed. All right, any last comments on the suffix effect before we move on? All right, so now we're going to take a look. We're going to shift from the short-term memory, working memory type questions, and we're going to start our look at long-term memory. We're not going to finish it today, but we're first going to take a look at types of long-term memory. So we were taking a look at types of memory, short-term working memory and long-term, but there's also been types of long-term memory that have been identified, and evidence has been gathered that these are indeed different types of memory systems in our long-term memory. So the big divide, the big kind of different categories, is the difference between explicit memory, and this is memory that is used with awareness. Oh, okay. Well, we'll talk about the second part in just a sec. So the first big category is explicit memory, and this is memory that you use with awareness. This is memory that you are conscious of actually using it and having it and knowing it. So this includes things like episodic memories. So episodic memories is a memory about things that happen to you. This is memories about episodes from your life. So if you remember where you were, when the towers came down on 9/11, that's an episodic memory. If you remember that Christmas, that was, the best Christmas ever, that's an episodic memory. If you remember taking exam number 2, a couple of days ago, that's episodic memory, and you're aware that you have those memories. You bring them into consciousness. You know that you have them. They're explicit. The other major type of explicit memory is semantic memory. And these are things that you know, facts that you know, and you don't necessarily know why you know them or where you learned them. So your general knowledge falls into semantic memory. So if you know that George Washington was the first president of the United States, you might have no episodic memory of learning that. You might not be able to go back and say, oh, that's right, grade 1, Mrs. Dreyfus, she told me, and I exactly remember why. No, but it's a memory that you have. It's semantic memory. So episodic memory, memory for your life. Semantic memory, this is the facts, the knowledge that you have. And the two of them can be combined. You might have a semantic memory and you remember the episode where you learned it, but they're two separate forms of memory that are part of your explicit memory, things that you know. The other major category in long-term memory is implicit memory. And implicit memory are memories that you use without awareness, memories that you clearly have, but you might not have explicit conscious knowledge of exactly how do you do it. So one of the things one of the forms of implicit memory is procedural memory. How do we do things? How do we do the things that we can do, for example? So procedural memory would cover any skill that you've ever learned. So if you know how to throw a baseball, you clearly have memory for how to throw a baseball. So if somebody gives you a baseball and they say, throw this, and you're able to, throw that baseball, well, then clearly you have information stored in terms of how to throw a baseball. You have that procedural memory. If somebody asks you or says, oh, here's this person here that doesn't know how to throw a ball, teach them how to throw a baseball. You might sit there and think to yourself, I don't know how I do this. You just kind of, you grab it and you throw it. You throw it, right? That's procedural memory. You can do it, but you don't know how. It's memory that you use without awareness.
Is that like muscle memory?
Muscle memory is another form of procedural memory, where again it can be procedural. It might be priming. We'll see that in just a second. But muscle memory would again be something that you don't necessarily have conscious awareness of. And this is one of the reasons why oftentimes in sports, people who are naturals in sports oftentimes do not make the best coaches later on. Because when they were learning to do things and somebody said, hey, try to throw this baseball, they were like, all right. And it's like, perfect. That's great. That's exactly what you want to do. They're usually not the best coaches because they got that procedural memory. But if you want to coach somebody, you got to take that procedural memory, you got to move it up into your semantic memory. You got to be able to say, all right, you grab the ball, you point 1 foot towards where you want to throw, you hold the ball up here. You need that step-by-step knowledge, and that you cannot get from procedural memory because, again, it's that memory used without awareness. Another form of procedural memory are things like priming. So priming we use once again without awareness. This is where if you're presented with one piece of information, you will be more quickly able to access another piece of information. And this is basically revealed oftentimes in associated pairs of words. So if I say something like doctor, hands up if the first word you thought of was nurse. Right, those two. Nobody? What did you think of? Stethoscope, office. Okay, so stethoscope and office. That's an example of priming, because you cannot bring up stethoscope and office without some sort of prior memory that those things go together. But it's a priming effect where you're unaware of necessarily doing it. So, Batman, you think of Robin. If you think of, I'm running out of words. Basically, that's one example of priming. This is one of the reasons why, or one of the areas of memory that is highly investigated in terms of biases, in terms of things like sexism, and in terms of racism. So priming is very important because oftentimes that first thing that you associate in memory is what kind of drives your judgment. So if you see African American and your first thought is violence, then you are primed to interpret things in that particular manner. If you see African American and your first thought is doctor, well then you are primed to think of it in a different way. And priming is one of the big reasons why representation in media is so important, because we need to basically make those associations, right? We need to have those presentations of here's one stimulus and this is what it goes with. So there's an entire generation of individuals who were not primed for Batman Robin because the first two Batman films in Tim Burton's run did not have Robin. And all of Chris Nolan's run did not have Robin. And we still don't have Robin, right? What happened to Robin? There's going to be a whole bunch of people who see Batman and don't think Robin. And that's one of the reasons why you want representation in your media, so that we can have a generation of people that see black man and don't think drug dealer, see black individual, don't think gun, see black individual and think instead, President of the United States, right? So we're going to see that coming up later. And again, this is memories that are used without awareness, and that's one of the things that makes it so important. And the last one is conditioning. This one can also fall under muscle memory. Conditioning is when you have associations that were made by repeated presentations, and also important in sexism and racism. But again, this is without your awareness. So conditioning occurs oftentimes in phobias. You might have somebody who's afraid of heights, and you ask them, why are you afraid of heights? Did you ever fall out of a tree? And they're like, no. Did you ever get stuck up in on a ladder? And they're like, no. Did you ever have a bad experience with falling, with heights? No. But you're afraid of it? Yes. So somehow they got conditioned. They don't have the awareness of it, but they're afraid of it. And this can also be muscle memory. One of the examples that comes up with that is flinching, right? So if you got hit in the face with a ball, the next time you see that ball coming, you're going to be like, oh, you're going to flinch. That again is used without awareness, but is a form of that implicit memory. So implicit memory, one of the forms of memory, and again, it's that idea that we have memory. We definitely have memory for something that we can do things with, but we might not be at all aware. We don't have that awareness of what that memory is. So we are at this weird time where I don't know if we got enough time to launch into the CogLab, but we'll give it a shot. We'll see how far we get. Maybe we'll get to the results of this, and then we'll talk about what it means next time. So let's take a look at some evidence for implicit memory.
How is this memory? I was just pressing where the dot was.
You'll see. You'll see in just a minute.
This is so, I don't want to say stupid, but.
No, like you'll be you'll be amazed at how many seemingly trivial things, and that's a good thing to always remember. Things in the lab are almost always trivial, right? There is nothing important whatsoever about remembering 9 numbers in a row, right? Nobody is ever going to come up to you and say, the fate of Indiana depends on you to be able to remember these 9 numbers, right? I hope it doesn't happen that way, but that doesn't happen. And yet it tells us about how our memory works. That idea that we cannot filter information out consciously is huge. It's very important. You're going to see that this is also one of those indications that'll show you, in this case, it's called implicit learning, but it'll show you whether or not you develop this implicit memory. On a side note, I remember, and I mean, I know some of these are tedious. I remember when I was doing my PhD thesis, I had people judging pictures of and the sizes of tiles in pictures. So I'd basically put up a tile and I'd be like, how big is that tile? They'd give me a number between 0 and like 600. How big is this tile? How big is this tile? And I remember one subject walked out and I was like, do you have any questions? And he's like, no, but he goes, I just got to tell you, that was the most boring experiment I ever did. And I was like, I know. I wish it was exciting. It's not. But anyways, so implicit learning, let's set it up. So on each trial, you saw a dot appear in one of the 4 locations. And your task was just to press one of the 4 keys on the keyboard to indicate where that dot was. And you were asked to respond as quickly and as accurately as you could. And the independent variables for this, or the independent variable, was that there was actually 2 presentation conditions. So there was one condition that was completely random. And in the random condition, the dots, they never followed a pattern. There was no pattern to where the dots would occur. You had a 1 in 4 chance that it was going to occur in any of the locations. Some of you were in the random condition. Others of you were in the pattern condition. And in the pattern condition, the dots followed a specific pattern, and that was only dropped in block number 5. So blocks 1 through 4, you had a very specific pattern. Block 5, it went to random, and then in block 6, they reinstated that particular pattern. So they were basically, again, you saw this, far left, left, right, and far right. So you would just indicate where the dot was, just press it as quickly as you can. But unknown to some of you, you were in the pattern condition, and others were in the non-pattern condition. So we actually we'll introduce this, and then we'll discuss what happened next time. So we'll take a look at the results for the random condition. So here we have the reaction time. How long is it taking you to indicate where the dots are? And here we have the blocks, right? This is basically your experience, right? So with more and more experience, with more and more learning, were you able to get better? Basically, were you able to drop your reaction time? So for the random condition, we have this line right here. And what this is indicating is that at the beginning here, versus the end, you actually got way better. So by the time you were done with this experiment in the random condition, you actually got better, but it's not possible to know whether this is explicit learning or implicit learning. So is this explicit learning where you just over time learned conscious information? You got better because of conscious information, like you press W when it's far left. You press M when it's far right. What was that number? Oh, the letters. Okay, you press Z when it's in the middle left. So this could be because you just got better at remembering which buttons you needed to press. This could also be because of things like muscle memory or implicit learning, where you got better the same way you get better at throwing a baseball. You just got better at pressing those buttons. So this one here could be a combination of explicit learning, you learned where the numbers were, and implicit learning. That was a random condition. What happened for the pattern condition? Well, there's your random condition right there. And if there was some sort of implicit learning, specifically if individuals were able to learn the pattern, what do we expect for the line with the pattern condition? Is it going to be higher or is it going to be lower than the random line here?
Lower.
It should be lower. So if you were able to learn the pattern condition, if you were able to learn what that pattern is, it should be lower. And in effect, and there it is, it actually did get lower. So this difference here, that can only be because of implicit learning. Or the evidence is very strong that it's in implicit learning. And I'll demonstrate that it doesn't have to do with explicit knowledge. So half of you, when you did this CogLab, you were in the random trial. Half of you were in the pattern trial. Who thinks that they were in the pattern trial? Okay. Who thinks they're in the random trial? Who has no idea? All right. So most of you don't know if you were in the random trial or you were in the pattern trial. For the people that were in the pattern trial, does anybody explicitly know what the pattern is? Did anybody identify it's left, left, far right, left, far right, right, left, right? Anyone able to do that?
My like last one, the fifth one was pattern, but all the rest were random.
I thought it was.
The fifth one was actually random for everybody.
Yeah.
Yeah. The fifth one was actually random for everyone.
Pattern and the
Yeah.
other ones were random.
I think
And
my score went
I
up
remember my
5.
pattern one.
So what was your pattern?
It would go like left. It was right, far, left, far, left, something like that. It would go like from this way and then flip over that way.
It would go from, so it was like far right, left.
Yeah.
Something like that. Okay. But for most of us, we weren't able to detect a pattern, and we'll see next time if that was actually the pattern. One thing that we saw before, remember in the face perception, is that sometimes we see patterns when they actually aren't there. But importantly, there is a difference here in performance. You can see that it got much faster, much quicker. Now, this drop here hardly has to do with explicit learning. You learn where to press the buttons. You learn where your fingers are supposed to go. But this difference here, if you cannot tell me which condition you were in, and importantly, if you were in the pattern condition and you cannot tell me what that pattern was, that means that you did not explicitly learn or have an explicit memory for what that pattern was. But you could clearly use the pattern. So you were clearly quicker in the pattern condition. So the ability to use that pattern indicates that you've learned it, indicates that it's stored in your memory. The inability to remember what it was, however, indicates that it's not explicit. So this is a very strong indication of an example of implicit memory. You're able to use that pattern, but you can't bring it to knowledge. It's not part of your explicit memory. All right, so we're going to end it there for today. We'll pick it up here next time that we meet as we continue to look through our exploration of memory. Other than that, if you came in late, find a sign-in sheet. Where's it at? Make sure that you sign in, and I'll see you all next week.